Welcome, everyone. Little brief introduction of myself, and then we'll look at the agenda. I've been spending the last 12 or 13 years pretty much speaking about Windows internals, reading about Windows internals, writing about Windows internals. This is the latest in a series of books that was originally titled Inside Windows NT. This is the fourth edition. We decided to rename it Windows Internals instead of Inside Windows. If you stay to the end of the day, I will sign your copy of the book. And we're finishing at around 9 p.m. 9 o'clock tonight we'll be done. No, I'm just kidding. Before I started spending time in working with the Windows kernel, I spent 10 years in the VMS operating system development group at a company once known as Digital. May we please have a moment of silence for Digital? Okay. Later we have a moment of silence for Compaq. So anybody here go back far enough to have worked with VMS in a past life? Okay, so this is the same thing basically, right? They just changed the name. But having worked with the VMS kernel as a developer, it was quite natural to move into the world of NT. I had worked with Dave Cutler. Some of you might know the name. Dave Cutler was the guy that Bill Gates hired in 1989 to create what is now Windows XP, Windows Server 2003. And he actually wrote a little bit of an introduction to the book. There's a picture of him with us. And he is still working on the NT kernel. Now, of course, when I say NT, I mean Windows XP, Windows Server 2003, Windows 2000, NT4, the NT code base. He is actually still coding. He works every day. The last couple of years, he's been mainly focused on the 64-bit work. Although he's done some pretty important scalability changes in Windows Server 2003 that permit scaling the system into much larger multiprocessor environments, and that applies to both the 32-bit and 64-bit system. So he's kind of our main contact, technical contact. In fact, this content would not exist without his giving me access to the Windows kernel source code. And that is how the information in the book was developed, was reading the source code. I've had access to the Windows source code since about 1993. And for that, I'm very grateful to Microsoft because it's obviously been a key resource for the work that I do. So the last 10 years, my work is strictly focused around teaching Windows internals, writing about it. The material I've selected today is aimed at helping you dig a little bit under the hood or look under the covers to try to get a better idea of what's happening inside the box. I feel in a way we're going to try to take a stethoscope that a doctor would use to listen to the heartbeat and try to understand maybe why the patient is sick, or in some cases, why the patient has had a heart attack, and how we can resuscitate the patient using some of the debugging tools. By the way, please do not be alarmed. This is not a real emergency. This is only my wallpaper. And the reason this is my wallpaper is that Windows XP is so stable that I have forgotten what the blue screen looks like. And I like to be reminded back in NT4 when we had blue screens. So that's what Microsoft told me to say about this wallpaper. We're going to start out with troubleshooting process and thread activity, what tools are available to take a stethoscope, listen carefully to what's happening inside the box, try to put some roles and purposes on some of the system processes in the process list. We're going to look at how to peer inside a process to understand the individual thread activity, how to, for example, figure out when a service host process is consuming CPU time, and it may contain multiple services, which service is responsible for that activity. We're also going to explain some what look like strange results. When you look at the CPU time counters, many processes in the system appear to have accumulated no CPU time. How is it possible? We're going to learn why these numbers really don't represent anymore where the system is spending its time, why that is, and how you can, with some different performance counters, understand where system time is being accounted. We're also going to cover how to account for interrupt time, which in Task Manager, strangely enough, is included in the idle process time. So if you have a device that's going crazy generating interrupts, your system, according to Task Manager, will appear idle. interrupt time is included in that number. So we'll see how to break that apart. So that's part of the process and thread troubleshooting. The second part, we'll look at memory-related issues, what's some of the meaning behind the core performance counters. In fact, if you look at the lower part of the Task Manager Performance tab, we'll give some crisp definition to what is available memory, what is system cache, what is the commit charge. And also, you see the bar that says PF usage. That's not the page file usage. We'll talk about what that is in the memory troubleshooting section. We'll also even talk about how big should your page file be if you cared to size it appropriately. The standard Microsoft recommendation on sizing your page file is, anybody know, approximately 1.5 times RAM, or RAM plus this, or RAM plus that, or RAM times this. Any formula that sizes the page file as a function of RAM is by definition brain dead and ridiculous and based on utter fantasy. And probably will yield a page file that's way too big, which doesn't matter. But we'll look at what performance counters would be used to appropriately size the page file if you cared to. All right, so here we go with part one, process and thread troubleshooting. Let's just sort of start from the most basic issue. Your system is either feels slow or you recognize there's some unusual CPU activity. And of course, most people bring up Task Manager and they look at the list of running applications. And so what is this really a list of? Because there is no such thing as an application at the kernel level. That means nothing. There's also no such thing as a task. So neither of these terms represent any object in the system that the operating system keeps track of. And I think many of you may know that this Applications tab, I'm jumping forward to slide 9. We'll come back in a second. This Applications tab is really a list of windows. And it's not even all the windows. It's some of the windows. To me, the tab should be called the Sum Windows tab, because that's what it is. It's some of the windows. It's windows that meet a very specific set of style criteria. So there may be windows or message boxes that are on the desktop that do not appear in the list. Task Manager has a very specific criteria when it enumerates the windows to be listed there. It is also not all the windows in the system that meet that criteria. It's the windows in your session. So if you're on a terminal server, obviously you don't see the windows of another user's session. So it's the windows that meet a specific set of criteria in your session. That means also on an XP client machine with fast user switching, which you lose when you join a domain with XP Professional. So either XP Pro or XP Home that is not a member of a domain. Multiple users are logged in with multiple sessions. It's showing the windows in their session. The running column is not the status of the window, because windows don't run. Threads run. And running is displayed only when the thread that owns the window is not running. Running is displayed when the thread that owns the window is not running, but waiting for a window message. So running means not running. And not responding, which you've probably seen, means not waiting for a window message. That's all it means. It doesn't mean the thread is running. It means it's not waiting for a windowing event. It could be in a loop doing something, or it could be waiting for some I/O unrelated to a Windows message event. So unless it's waiting for a Windows message, it says not responding. When it's waiting for a window message, it says running, which means it's not running, it's waiting. Now, I introduced the term thread, so let me go back and talk about processes and threads. So if you look at slide 8, 1-8. Let's just give a crisp definition here, because these are terms we're going to use for the rest of this first section of the day. A process is a container that defines a set of resources used by threads. Threads run, processes don't run. So it's incorrect to bring up Task Manager and look at the process list and say that the PowerPoint process is running because processes don't run, threads run. Every process has at least one thread. Now, PowerPoint is an example of a multi-threaded application. How can we tell if it has multiple threads? Well, we could add the thread count column, which I actually have already configured. It's scrolled off to the right. And sure enough, PowerPoint has, can you see the number on the right, 14 threads. And that's true of the Microsoft Office applications. They actually make intelligent use of multiple threads. For example, when you do a file print in Word or PowerPoint or Excel, you can, unless you turn it off, continue to edit the document while the print spooling is going on because it has a separate thread sending the data to the print server, separate from the thread that owns the window that you're interacting with. So that's an example of taking advantage of multiple threads within a single process. Contrast that with something like Notepad, which is a dumb single-threaded application. And you know on Notepad, if you type a long document and then print, while it's printing, you can't edit in the editing window because the thread that is sending the data to the print server is the thread that owns the window. So that's an example of a simple single-threaded application that can't do more than one thing at one time. So threads run, processes don't run. Threads share the private address space. There's no protection between threads in a process. So the responsibility to synchronize access to data within the process address space is the programmer. And Windows provides several synchronization mechanisms that allow a programmer to keep their threads from stepping on each other or, for example, updating a data structure at the same time as another thread. An example of that is the critical section object. You might have also heard of mutexes, semaphores. And how those are used is outside of the scope of what we're discussing today. I think we're going to see, as users, more issues with multi-threaded applications as we move forward into the next generation of processors. What's the next generation of processor implementations that are coming out this year from both AMD and Intel? Multi-core. Not hyper-threaded, multi-core. And even with hyper-threaded processors today, there's more of a chance of multi-threaded synchronization issues. And I say that because if you think about a single processor, like my laptop, there really is never more than one thread running at one time. I only have one processor. There still could be issues with a multi-threaded application in that the OS, for two threads at the same priority, interrupts one thread, saves its state, and schedules another thread. So even on a single processor system, the programmer has to provide synchronization to resources within a single process because although there's never more than one thread running at the same time on a single processor, the threads in a single process could be being preempted because of their time slice expiration. Threads run on Windows XP by default for 20 milliseconds before another thread at the same priority gets a turn. These details are in the book. And by the way, that number, 20 milliseconds, hasn't changed since 1990. That's been true for desktop Windows systems, NT systems, since it came out. On servers, turns out threads run 6 times longer by default. And that's because on a server, it would be better if a thread, when it wakes up to run, could get all of its work done and voluntarily enter a wait state, rather than the system coming in and taking the CPU away from that thread and giving another thread a turn. Because that context switching, the act of the system interrupting the thread, taking the CPU away and giving it to another thread is, if you think about it, wasteful operating system overhead that accomplishes sharing the CPU fairly, which is a good thing, but it introduces inefficiencies into the throughput. So that's why on servers, threads get a longer turn. Doesn't mean they're going to run that whole turn. It means they could run that longer turn. On a workstation, you'd rather have quick responsiveness. When you click on a window, you'd like to see some response right away. So it makes sense that the length of the turn for threads is shorter at the expense of overall throughput. By the way, you know that you can choose, since Windows 2000, long turns on client machines or short turns on servers in the advanced performance settings. So I'm going to My Computer Properties. Now, in Windows 2000, this was under the advanced performance settings. On XP, it's under advanced performance settings, really advanced. If you get here, you better know what you're doing. In 2000, it was advanced. In XP, it's advanced. But essentially, it's the same dialogue. Well, that little thing on the top that says processor scheduling, that radio button chooses short turns or long turns. If you read the sentence, it actually kind of is almost humorous. It says, by default, the computer is set to use a greater share of processor time to run your programs, as opposed to what? Somebody else's programs? So the sentence may not be clear, but in fact what the radio button is choosing is short turns or long turns. So an example where you would take a server and flip it to the program setting would be a terminal server. You want users on a terminal server to have the quick responsiveness that you would get on a client machine. So when you configure a terminal server, it makes sense to set it to programs. On the other hand, why would you take a workstation, a client machine, and switch it to background services, which is really means long turns? For example, you are a strange computer geek that runs server as your desktop OS. Anybody here run server as their desktop OS? Raise your hand. So there's a few in the crowd. And there's sometimes a good reason for that, although less and less. So if you're running server as your desktop OS, did you make the setting change to programs? So you have the pleasure of short time slice intervals. Isn't it wonderful? Okay. Anyway, so back to the issue with dual core. With hyper-threaded processors today, you know that there's still one execution engine. It's the chip that's switching between two instances of the OS. The OS thinks there's two processors, but there's one. So there are some cases where there's two threads in the same process that are virtually running simultaneously, that on a hyper-threaded system are going to run into cases, synchronization issues that wouldn't show up on a single processor. But if you think about a true dual core, which is a real dual processor with two execution engines, there will be cases where there are two threads in the same process literally running at the same time. And that may hit race conditions or timing conditions that just never occurred before. So it's my prediction that we're going to be faced with random application failures for multi-threaded applications that just never ran on dual processor systems very much, because we're going to be running dual processors more and more, both on desktops and laptops. Just as a side note, there's actually a bit that you can specify in an exe that forces the executable to be uniprocessor. And this bit has actually saved both myself and my co-author Mark Rusinovich with bugs in a Microsoft slide presentation tool. I don't want to mention which product. And we had the case where this slide presentation tool, which shall remain anonymous, was failing on our dual processor desktops, getting an access violation, never failed on our single processor laptops. And it turns out it was a race condition, a synchronization bug, that has since been fixed. This was an older version of the slide presentation tool. But as a workaround, we set this magic uniprocessor bit in the exe header. And the tool to do that, if you want to make a note, is imagecfg.exe in the Windows 2000 Server Resource Kit Supplement 1. It wasn't in the original. And it's been removed from the 2003 Server Resource Kit tools. Just as an aside, the 2003 Server Resource Kit tools have half the number of tools as the 2000 Server Resource Kit. Half. They removed half. For a good reason. The tools that they removed were ones that they couldn't complete security reviews for. Remember 2 years ago, Microsoft had that big security push where they stopped all development for a month. So the Resource Kit tools, they were only able to complete the security reviews and fixes for half of the tools. So that ImageCFG still works on XP, but it's from the 2000 Resource Kit. And if you want to make a note of the switch, it's the -U, or uniprocessor switch. So you can set that on an exe. For example, ImageCFG -U, PowerPoint.exe. Oops, I wasn't supposed to mention it was PowerPoint. So literally setting that bit made the problem go away, because every time we ran PowerPoint on our dual processor desktop, the OS assigned what's called the hard affinity of the threads in that process to one of the CPUs. It would pick which CPU, but for that process, its threads would only run on that one CPU, which means its threads would never be running at the same time. So I mention that because I think you're going to need that bit as time goes forward with apps that have strange failures on dual-core systems. And there are bugs in the application, clearly, but they've just not surfaced. So that's a nice little workaround bit to remember if this hits you over the next year or so. So that's just a quick description of the model processes and threads. So processes define a private address space, a set of resources that we're going to look at later called the open handle table, such as the open files. And also each process has a set of security credentials, which we're also going to look at, called the access token. Now, going back to Task Manager, Task Manager does provide a way, given a window, to map to the process that owns the thread that owns the window. So, for example, if I bring up Task Manager, go to the window list, and do a right-click, go to process, what is that going to take me to? PowerPoint.exe. But I don't know which of the 14 threads in PowerPoint owns that window. That is something that a Microsoft tool called Spy++ can show. Task Manager doesn't show that mapping. So Task Manager takes you to the process that owns the thread that owns the window. In that case, it's Explorer.exe. Now, we go back to our scenario. The system is either running a bit slowly or there seems to be some process whose threads are consuming a lot of CPU time. What is this thing that's consuming CPU time? And often, simply looking at the name of the image is enough. Notepad.exe, PowerPoint.exe. But wouldn't it be more helpful if there was some additional details around the image name? For example, the full path. If you knew the full path, that would be helpful, if it was something you didn't recognize. That is something that in XP, finally, there's a command line command to show the process list with full paths. And it's the task list. Task list. Which, by the way, doesn't show the task list. It shows the process list. So there is no such thing as a task. In fact, if you think about it, Task Manager, there are no tasks to manage with Task Manager. Tasks don't mean anything. There's a switch that will show the full path. But that doesn't help you if the process that's consuming CPU time is what I call a multi-purpose process, a process that inside is running code from several different DLLs. A good example of that is SVC host. If an SVC host process is consuming a bunch of CPU time, which service is it? So in that case, you need to drill down to what granularity? The thread. Find out what thread is running, and then find out what piece of code that's running. We're going to see how to do that fairly easily with a tool in just a moment. And so the tool I'm going to use to kind of drill into process and thread activity for a number of the demos upcoming is a tool from sysinternals.com called Process Explorer. This is a freeware tool. There's no cost to use the tool. Let me ask right now, how many people here have used Process Explorer? Wow, look around. Keep your hands up. Look around. So that's about 2/3. Who's never used Process Explorer? Raise your hand. Never? Okay, you can leave now. So it's a freeware tool. There's no cost. I will just stop briefly and say something about the tools on sysinternals. Process Explorer is one of about 70 freeware tools. This website, sysinternals.com, is maintained by my co-author, Mark Rasinovich, who wrote the last 2 editions of this book with me. Just a comment about the tools that I think I have to say to be fair. Most of the tools on this site that are, to me, the most interesting ones, load a device driver when they start. And the reason they load a device driver is that they're crawling into the OS kernel memory to pull out information about the state of the system that is simply not available from any of the supported programming interfaces, which is what makes them useful. So Process Explorer, for example, when you start it, loads a device driver, and it uses that device driver to obtain some of the information that is quite useful for process troubleshooting. Now, why do I say that that's a little bit of a warning? What can drivers do that is potentially quite bad for your system? They can cause these beautiful colored screens. And in my, 6-7 years of using Mark's tools, I've had 2 issues where I've had blue screens on production servers. So that's, to me, pretty good. If you do get a blue screen, tell him about it. He wants to know. Get the mini dump, send him the mini dump. His email address is on the site. It's very simple. It's mark@sysinternals.com. And if you don't get a response, send him another mail and say, Dave told me to send you this. But he is interested in fixing the bugs. Microsoft Product Support, in a way, has blessed these tools because they have customers download and install and run these tools all the time. They use them every day in their business. There are over 50 Microsoft knowledge base articles that point to sysinternals tools. So I'm not trying to scare you or tell you that these are bad. Microsoft, in a way, has silently kind of blessed them. But they do load a driver. And device drivers have full access to kernel memory. Just like threads in a process have full and equal access to their own private address space, on the NT kernel, all the drivers live in the same address space as the OS. By the way, for some reason, there's this set of people in the world that believe that the Windows kernel is somehow less reliable or structured in a way that makes it less reliable than that other kernel that begins with the L. I won't say it, the L word. You know, the L word. I'm not allowed to say it. And that's just complete nonsense because those kernel designs are identical. On Linux, all of the drivers live in the same address space as the kernel. It's the identical same kernel architecture. So why does Microsoft seem to get blamed for being susceptible to blue screens? More so than Linux. Anybody have a comment? They do. Yeah, they're doing quite well. Say again? There's more device drivers. The number of device drivers for XP is staggering. And I have a slide in the crash dump section this afternoon which quotes some public numbers from Microsoft that have been generated because, you know, since XP, there's an option when you reboot after a crash to send the dump to Microsoft. Anybody ever pressed send error report after a blue screen? You know where those go? There's a big warehouse out in Seattle. All the programmers that were found to introduce security bugs are banished there for 1 year. They chain them to the desk, and they have to fix blue screens for 1 year. And they're only fed once a day. So when you send that error report in, just think about the poor programmer there who's going to analyze that. But seriously, because they're collecting these crash dumps, they've been able to do some very interesting analysis that has been able to help them to go after third-party device driver manufacturers that are causing the most number of blue screens. 8 out of 10 of the crashes are non-Microsoft drivers. 8 out of 10. But when the system crashes, who looks bad? Windows looks bad. 8 out of 10 crashes are third-party drivers. Linux simply doesn't have as many third-party drivers. There are over 30,000 different drivers on XP, and those numbers were as of 10 months ago. 30,000 different drivers. That's mind-boggling. So if Linux ever has that many drivers, they're going to have the same issue. The problem is there's a lot of idiots writing device drivers. And there's no license that you need to get to write a device driver and post it on the internet. There's no certification required to post a driver. How many of you have ever installed an unsigned driver? You get the little warning. Who presses proceed? Does anybody not proceed? Everybody proceeds. And by the way, just because it's signed doesn't mean that it's necessarily bug-free either. But I think most of us are running unsigned drivers. I have 20 unsigned drivers on my laptop right now. And if it's unsigned, then there's no guarantee that they've gone through even some of the basic verification steps that to get the digital signature you have to go through. Anyway, we'll talk more about driver issues in the crash section. But I just wanted to make clear that when you run FileMon, RegMon, Process Explorer, and some of the other tools, you're loading a driver. Loading a driver is a pretty important step to take because you're introducing a piece of code that can bypass security and that can crash the system. Now, Mark's drivers don't have any purposeful bugs in them, and they don't go and bypass security. There's no spyware, but I think it's only fair just to alert you to that. And by the way, those drivers are packaged in kind of an interesting way. When you download the tools that have drivers, you won't see the driver. The driver is inside the exe. So inside Process Explorer's executable is a driver. When you run Process Explorer, it extracts a driver from its belly, creates the driver in the registry, loads the driver, and then deletes the driver from the registry and deletes the driver from the hard drive. There's no record of it anywhere on your hard drive. Drivers can be deleted once they're loaded. And later we're going to see how can one look at the loaded driver list and find out really what's been loaded, as opposed to what the system tools tell you has been configured. Those tools look in the registry, which won't show up drivers that have been loaded but deleted from the registry. Now, why does Mark do that? He's not trying to be sneaky. He's trying to be tidy. So he's trying to clean up. So his drivers are deleted after they're loaded. Okay, let's use Process Explorer now to just start to drill into some of the process and thread details that we've alluded to. And if I start Process Explorer, which I have running already, one of the things that is different about the way the process list is shown, just kind of visually, is the tree structure, the hierarchical display, as opposed to the flat list that Task Manager shows. Now, that's not something unique to Process Explorer, because Microsoft has had a tool for years that shows the process list in a tree-structured fashion, and it's called T-List, which is, again, a tool with an incorrect name. T-List means task list. This is showing the process list. It has a switch /T, which shows the tree. T-List /T for tree. So they're both showing the same information. What is the process tree? Well, it's really just there on an informational basis. There's nothing that happens to a process when your parent exits. There's no notification to the child. There's nothing bad that happens to the child. So a parentless process has no different state than a process with a parent. The Windows kernel only keeps track of your parent. So when a process is born, the system records in the process block of the child the process ID of the parent. But if the parent exits, there's no way to find out who was the grandfather. So how does T-List in Process Explorer show the process tree for a process who has no parent? It left justifies it. For example, if I scroll down, these processes have no parent. And actually, I'm kind of in a strange state. I should have rebooted or logged off and logged in. I had purposely, a couple of days ago, caused the Explorer process to crash. And Explorer, when it crashes in a certain way, is automatically restarted. Ever had Explorer crash and then it restarts? The start button reappears. Well, notice who the father of Explorer is if I scroll up. In fact, I'll try to collapse the tree here so you could see it a little easier. Who's the father of Explorer.exe? WinLogon. So in fact, it is the logon process that restarts the shell when it crashes. And by the way, that doesn't always happen. Explorer has to exit with a certain status code for WinLogon to restart it. For example, if you kill Explorer.exe with Task Manager, it doesn't restart. So it's when it crashes. It actually sets an exit status that is its way of telling the logon process, I'm dying, please recreate me. But if you kill it with Task Manager or any of the kill tools in the system, it doesn't restart because it doesn't exit with that special magic status code. So that's why on my system, Explorer has the parent WinLogon. That's not normal. All of Explorer's children, before it died 2 days ago, are down on the bottom as parentless processes. In fact, look at Process Explorer. Process Explorer itself, I had run from Explorer, from the previous Explorer which died. So those are parentless processes, which doesn't mean anything. Doesn't matter if you have a parent or you don't, in terms of the process tree. So I guess to me what's interesting about the process tree is when there is a parent, it's helpful to see where the process fits into the structure. By understanding who the parent is, you have some idea of why it's there, who made it. It's purely informational. I think it's a useful piece of information. Okay, so that's one interesting thing Process Explorer shows. Now, by the way, these slides that say lab, when I'm doing this class in a classroom, everyone has a computer and you're running through these steps. So these are things that you could go back and try on your own. I'm going to be demonstrating them. If you look at step 7 and 8, by default, Process Explorer is configured to show the description and company name. Now, where is that coming from? The exe itself. So who's responsible to put in the company name and description? The programmer. And they can put in whatever they want. For example, I'm running a little process that is reporting itself as the Windows NT Logon Helper application by Microsoft Corporation. In fact, it's a tool, it's a demo program that Mark Rasinovich wrote to show as an example how one could provide a piece of spyware that, according to this information, you might think is part of Windows. Because you can fill in whatever you want. So the description and company name really are, in a way, kind of meaningless. You can't trust it. However, I still think it's useful to, for example, sort the process list by the company name. Now, by the way, I just sorted the list. We lost the tree view. So if you sort by a column, you can't have the tree view and sort. It's one or the other. You can go back to the tree view, view, show process tree. So if I go and sort by company name, it's kind of a nice, quick way for me to look at the non-Microsoft processes on the system and maybe go inspect them. But again, anybody can put in Microsoft Corporation in the process company name. It is also interesting to see how some vendors forget to put a description in, not picking on anybody in particular. That's sloppy. Or other examples where there is a description but no company name. That's a freeware browser wrapper that Mark and I use that uses IE. That's not Firefox. I would never use Firefox. That's against my religion. That is using Internet Explorer, but it's a shell that provides a tabbed interface, so you get some of the nice features that people talk about with Firefox. It's a tabbed interface, but it is using IE, which means it works on websites that only work with IE. There's another freeware tool similar to that called MyIE2. It's now called the Maxthon, M-A-X-T-H-O-N. Anyway, Avant Browser is one. There's another one. They're freeware tools. So that guy forgot to put a company name in. The other thing that shows up that's interesting is the full path. As I hover my mouse, take, for example, this is an executable that's installed in the Windows directory. That's generally considered bad practice these days for third-party applications to install themselves in the Windows folder. Many do it. For example, this applet, AGR-MSG, is part of the modem support for my modem. And they did put in a description, and I think they also have a company name. Yep. So there's the full path. And that's helpful because now it becomes very quick to see which component the thing is part of, in the case where it's in some specific program files folder. And that can be configured also as a column. Something else that I've found useful in understanding process activity on the system is being able to see the birth and death of processes visually. I'm going to demonstrate that with this little example. I'm going to put Process Explorer in paused mode by pressing the space bar. So I just press the space bar, and on the very bottom of the toolbar, well, it's not showing up. If you look on the very bottom in the middle, on the status bar, it says paused. So I'm going to go and run my favorite demo application, Solitaire. Go back and press F5, and there's the Solitaire process, highlighted in green. And when I exit Solitaire and press F5, it's highlighted in red. And when I press F5 again, it's gone from the list. Now you can configure the highlight duration. I usually keep mine at 5 seconds, so that if I come out of paused mode, I'm now refreshing every second, and go and run Solitaire. I'll see it highlighted for 5 seconds, and then the highlight disappears. And when I exit, it's going to be highlighted in red for 5 seconds, and then disappear from the list. That has, in a number of cases, helped me to understand strange stuff going on. Because if you think about it, if a process is being born and dying quickly, are you going to see that in this task manager list? No. And I've had several cases where, looking at performance issues on both servers and clients, there was a process that was creating a process whose child was exiting right away. In one case, there was a script that was in a loop creating a child process that was exiting right away. Well, that's not very efficient. Process creation on Windows is a generally expensive thing that should not be done frequently. And so with Task Manager, you just would never have seen that. We ran Process Explorer, and we saw green, red, green, red, green, red, green, red, and I said, what's going on here? And another example, a third-party virus scanner that a customer was running on their network, and I won't mention the vendor. We looked at the server. Performance was going down the tubes one day. They have about 3,000 client machines. And the clients were taking a long time to boot up and initialize. And it turns out that they were stuck waiting on the server that had the virus signatures. So we went to the server to look at why it was running so slowly. And we looked at the process list, and there were waves of green and waves of red and waves of green and waves of red. And it turns out this virus scanner creates a process for every client that connects to check if it has the latest virus signatures. That's a really inefficient, broken design for Windows, even on Unix systems. But process creation on Windows is even more expensive than it is on most Unix systems. And I talked to the vendor, and they said, you're right, that's a stupid design. They should have a process that basically is created when the system boots and sits there listening for clients and sends back results, not create a process for every client that connects. That's like the worst, most inefficient design. And they're going to fix that someday. But it made it quite clear what was happening on the server looking at the refresh highlighting. Now, of course, if a process starts and exits between the refresh, Process Explorer is not going to show it. Anybody know of a way to trace, to actually get a trace of process birth and death? Which is not what Process Explorer is doing. Process Explorer is looking at the list, and then 1 second later looking at the list. Anybody know a way to get actually a record of every process birth and death, a trace? There's a mechanism that's been in NT since 3.1. Auditing, process tracking. Security auditing, process tracking. That's one of the security auditing options. It's not really a security auditing thing to me, but it's in the security audit settings for the system. There's an option called process tracking. Process tracking causes the system to write an event log entry for every process birth and death. That's one way. Another way, if you want to make a note of it, in Windows 2000 and later, there's a mechanism in the system called kernel event tracing. Kernel event tracing. And the trace log tool, which is, I believe, part of the support tools. Let's see. Where tracelog.exe? Yeah, it's in the Windows XP support tools. It also was in the 2000 resource kit. So tracelog.exe, which is in the XP or 2003 support tools, has a switch to turn on event tracing of kernel events. And if you look at the switches, and there's quite a number of switches, but I'll just focus on one of these. When you enable it, by default, it is tracing every process and thread birth and death. You can turn that off. But when you turn on the tracing, minus start, it starts capturing every process and thread birth and death. And there's a second tool to process the output that I'll make mention of here. Trace rpt.exe produces the report. That is another way to get a process and thread birth and death trace. And that's Windows 2000 and later. If you look at the security information that Task Manager lists for a process, there's an optional column to show the username. But if you look at this, there's one pretty important piece of information missing from the username string. Anybody notice what is not shown about the username? It doesn't show the security authority, which could be a domain or could be the local machine. So the D. Solomon account turns out to be a local account on my laptop. But looking at this list, I don't know whether that's a domain account or a local account. Process Explorer shows the security authority. If I configure the username column, username, and let's scroll across, and there it is. So you can see it says Big David \D Solomon, as opposed to just D Solomon. So that's a little tidbit in addition to the for the security credentials. All right, let's take a look at some of the process details that Process Explorer shows. Now, some of these are details that you can derive from Performance Monitor or other process viewer tools that Microsoft provides. Some of them are unique. So I'm going to the Image tab. I just double-clicked on Explorer.exe to bring up the process properties, and let's take a look at the Image tab. Now, on the top, the image file information, the description, and the company name. Again, that's coming from the executable image. Now, what about that verified? That's kind of interesting. Process Explorer, by default, unless you turn it off, will verify image signatures. So that means that if an image is signed, it's verifying whether the signature is one that is trusted, and then says verified or not verified. So an example of an unsigned image I'm running is this little fake virus, this little test program that says it's from Microsoft Corporation, but in fact it's an unsigned binary. Well, that would be a clue. However, the fact that it was signed doesn't give you any confidence either, because it is possible, although it's much more difficult, for a signing authority to give somebody the digital signature for Microsoft Corporation. Now, they would be in big trouble if they did that. But there are many companies that issue certificates. For example, Mark Rusinovich recently got a digital signature certificate for the sysinternals tool. So if you look at Process Explorer today, it shows up as signed, I believe, verified by sysinternals. He's now signing his own images. So what does it mean that it's verified? Nothing. He got a certificate and he signs them. Now, he tried to get a certificate for Microsoft Corporation, but the company he requested that from wouldn't give it to him. That's good. But there are many, many signing authorities. So one could imagine somebody inappropriately granted a certificate for Microsoft Corporation. So you're now running some virus or spyware that appears as a signed Microsoft binary. So the fact that it's verified doesn't really give you 100% assurance that it really is from that company. It's pretty likely, but it's not 100%. If we look down at the bottom, there's the parent process, username, the start time. Actually, this is the only tool in the system that shows the start time of a process. That's also been useful for troubleshooting for me, being able to look at a system the next day that was perhaps stuck and seeing when did this process come to life? When was it born? What was the birthday? That's a useful tidbit, and that's something that Performance Monitor doesn't show, the start time of a process. Okay. Bring to front. I'm just going to make a comment about this button. I found that helpful when I've got several processes that own Windows, several instances of the same process. For example, I'm running 2 CMDs. Well, if I'd like to bring one of those to the front, boom. So that takes the window, the parent top-level window owned by one of the threads in that process, and makes it in the foreground. Looking at the command line, that's another useful tidbit about what a process was asked to do. For example, if I look at the command line for Explorer, there were no switches. Some shortcuts define switches passed to a process. The example that's on the slide is looking at the command line for the process that's created when you go and change the time. So I'm going to put Process Explorer in paused mode. I hit the space bar. I'm going to the taskbar in the lower right, and I'm going to double-click. And by the way, it's 3:58 a.m. in New York, not in Amsterdam. If I go back to Process Explorer and press F5, interesting. Run DLL32 was the process born. So that's another example where looking at the process highlighting might clue you into process names that are appearing that maybe you didn't realize were associated with some action. Run DLL32.exe turns out to be the generic host process for all control panel applets. So if you see a run DLL32.exe in the process list, it doesn't really mean anything because you don't know what it was asked to do. But if we look at the command line arguments, and I scroll over to the right, look at the last part of the command line, timedate.cpl. So that turns out that's a DLL with a funny name. CPL files are really DLLs with a different file extension. That was the DLL that this exe loaded that produced the GUI that we just saw. So the command line, to me, is a piece of process state that may be interesting to inspect. And that's not the only way to get the command line. That's another tidbit that comes from that TList tool that you saw me use earlier. By the way, TList, if you noticed in the path, is part of the Microsoft debugging tools, which is a free download from Microsoft.com. So TList space run DLL32 shows, among other things, the command line. See the command line right there? So we see the timedate.cpl. By the way, that helped me to formulate the right command line switches so that I could launch control panel applets directly myself. I could see the switches that were passed, and then I was able to make my own shortcuts that would open up control panel applets the way I wanted. Now, I don't know about you, but occasionally a window will pop up, and I don't know who it's from. A message box or some window appears on the desktop, and I don't know who created this window. Now, Task Manager does have a list of windows, but like I said, a more appropriate name for this tab would be Some Windows, because there are windows often that appear on the system that don't meet the criteria and therefore aren't in this list. So I've had several cases where I wanted to find out who owns this window. What process made this message box come up? Process Explorer has a window finder tool that you can drag over a window that will highlight the process that owns the thread that owns the window. Task Manager will give you that mapping if the window appears in the list. You saw that earlier. I can go to the process list and find out the process that owns that window. But if it doesn't appear in the window list, this might be useful. So let's do an example. Say, for example, this window. Is that one showing up in Task Manager's list? I'm looking. Does it show up in the list? Date and time? I don't see it. So actually, there's a nice example right there. Here's a window that doesn't appear in the list of windows from Task Manager. So let's use Process Explorer to find out who owns it. So I'm going to move this window to the side. I'm going to drag this little kind of crosshair over the other window, and you'll see some black highlighting so you know which window you've highlighted, and then I'm going to let go. So I'm dragging this little guy over, and notice the little black highlighting? When I drop it anywhere on this window, if you look on the right, Process Explorer just highlighted the process that owns the thread that owns the window. So that's a quick way to associate window with process. And I mentioned a tool called Spy++. That's part of Visual Studio. That goes a step further because that shows you which thread owns the window. Process Explorer is showing which process owns the window, but not which thread within the process owns the window. And you might be interested in that if you were trying to go inside the process to figure out what piece of code made that window. Again, in the case where the process is a multi-purpose process, like an SVC host, or iNetInfo, or DLL host, a process whose exe name by itself doesn't really tell you anything. In that case, you might be interested to know which thread made the window and go inspect what code that thread is running. So Spy++ will show you that as part of Visual Studio. The security token for a process, I mentioned, is one of the three basic pieces of state: the address space, the open handle table, and the security token. So this is a list of the groups that are in the token for this process, and also in the lower half, the list of user rights. Now, the reason there's a brief pause here is that my laptop is part of the Microsoft Redmond domain. It is now trying to resolve a security ID in my token that is in the Redmond domain. It's trying to talk to a domain controller in Redmond. I'm not VPN'd in. This is going to time out in a second, and that's because their domain administrators, or there's some Microsoft account that's part of the security token of my process. It's Big Brother. They're looking at my laptop when I connect. There we go. So one of the entries in my security token referred to some security ID whose name translation failed. So there's the username, and there's the list of groups that I'm a member of. And this is an interesting list because, as the slide mentions, this is sort of a resultant set of groups. Because if you have nested groups in Active Directory, this is the flattened list that was assigned to you when your token was created from the Active Directory. Some of these are groups that were assigned by me. For example, I made myself a member of the administrators group, and I'm also a member of the users group. The everyone group is not something that I decided. That's an OS assigned group. So you're going to see some groups that the OS assigned dynamically when the token was created, and some that you've assigned either from the local security database or Active Directory. The privilege list on the bottom is another interesting list, and privileges, or user rights as they're sometimes called, are assigned either to usernames or groups, and by default they're in the off position. They're disabled. So when you sign in, if you have the right to shut the system down or to back up files, you have the right to turn on the privilege, but it's in the off position. Programmatically, it's turned on by an application that needs that privilege. So for example, if I ran Windows Backup, it turns on the backup privilege, if you have it, so that it can open files to which you don't have rights to read. The example on the slide to illustrate this is the system time privilege. When I brought up the date time changing applet, it went and made a system call to turn on the change system time privilege, which by default is not assigned to a normal user. It is assigned to power users and administrators. So if we go back to Process Explorer and look at this run DLL, look at the security token, we're going to see the system time privilege has been enabled. Who enabled it? The code inside run DLL32. And that privilege is enabled just in that process. Each process, by the way, inherits the security token from the parent. So the initial security token for your session, created by WinLogon, is assigned to the initial process in your session. And we're going to look at that when we look at the process startup order. Again, we're waiting for this timeout because it's trying to contact a domain controller that I'm not connected to. And if I scroll down, sure enough, the system time privilege is enabled. If I looked at that same entry in Explorer.exe or in CMD, it's in the disabled state. Anybody here working with .NET, doing .NET development, have .NET applications at your site? Raise your hand. Anybody here working with .NET? So Jeffrey Richter, who's a well-known author, has written kind of the main Microsoft Press book on the common language runtime, worked with Mark Rusinovich to add some special support for .NET processes in Process Explorer. And first of all, .NET processes are by default highlighted with a bright yellow, just so that you won't miss them. I'm running 2 .NET applications. And that highlighting, by the way, you can configure if you don't like it. But those are the default colors. So if a process is running with the .NET runtime, there's an additional tab shown. Now I'm going to have to wait for the stupid timeout because I had focus set to the security tab. I'll just show it from the PowerPoint. There's a tab, a .NET tab, that shows some details about the .NET environment, like the app domains. App domains are like virtual processes within processes. They allow .NET to give the illusion of separate address spaces within a single NT kernel process. And it shows app domains. There's no other tool that enumerates the app domains for a running process. And by the way, it shows app domain creation and deletion with the refresh highlighting that you saw earlier. It also provides some easy access to the performance counters that the Common Language Runtime maintains. These are counters that you could look at with perfmon, but they're also visible here, and they can be configured as columns. So if you're doing .NET development, this could be interesting for you. Now, one of the highlight options that you might have noticed, I have, although it's a little hard to see with the projector, the service hosting processes on my system are highlighted with kind of a pink. That's not even showing up, is it? You know what? Let's pick a darker color. So I'm going to the highlight configuration, and I'm going to change the highlight color for service hosting processes. So let's pick something a little darker. Is that showing up? Whoa. And I think I'm going to also change the other one so it shows up. Own processes. How about that? Is that showing up? Okay, so service hosting processes are processes that are hosting one or more Windows services as defined in the registry under the key, HKey local machine, current control set, control services. Let's talk about what might be interesting to explore in regard to service hosting processes. If we look at the properties of a service hosting process, Process Explorer enumerates the services inside that process. In this case, there's one. And there's sort of 3 pieces of information shown for a service. Let me pick a service host that has more than one. For example, let's go and grab this guy. Nope, this guy. Yeah. So here's the service host with about 15 different services inside. There's 3 pieces of information being shown for each loaded service in this process. The name of the registry key. Now, I mention that because that's all that you get if you look at the list of services in a service hosting process using the tlist or task list command. And I'll use the new one because it's built into XP and later. I'll go to a task list /svc. Task list /svc. And if I scroll back and take a look, the processes that, let me do that again. There we go. There's the service host we were just looking at in Process Explorer with the 15 or so services. The names shown here are the names of the registry keys. In some cases, they're obvious, like the schedule service. But in some cases, the name of the registry key may not be such an obvious mapping to the service that you would normally see in the GUI. For example, let's pick what's the ERSVC? I don't know. Let's go back and look in Process Explorer. It's the error reporting service. And what is the error reporting service used for? Notice the description on the bottom, and that's something you would see in the Services Control Panel applet. It allows error reporting. That's the service in XP that was added that sends the dump to Microsoft for a process that crashes. So being able to see the display name and then also read the descriptive text might be helpful in looking inside a service process. Now, since I happen to pick a service host, although I don't have a slide in here, just a comment about why there are more than one. Because the whole reason for SVC host, which was introduced in Windows 2000, was to reduce the number of service processes on the system. And that was done to improve boot time and also to conserve system virtual memory. Each process takes up a bit of a precious resource called the system commit limit, which is something we're going to talk about in the memory management section. That was one of the numbers on the lower left part of Task Manager's Performance tab, the system commit charge and the system commit limit. Each process takes up a little bit of system commit, and that is something that has a limit. So that was done to reduce resource consumption. But in Windows XP, there's actually more service hosts than there were in 2000, but that's because of security. And security is more important than resource consumption. If you look at the username that some of these services are running under, let me just get rid of some columns here. Okay. In XP, Microsoft added a couple of new security credentials, local service and network service, that services that in the Windows 2000 that ran under the system account now run under accounts with less privileges. So as part of their security review, they went and found that several services running under the system account didn't really need local administrator rights. The system account has local admin rights. By the way, how could you prove that with Process Explorer? Because you don't see the system account in the list of accounts. You can't inspect its properties. You can't change its properties. But remember that security tab. If I look at the security tab for one of these service hosts, that shows the details of the token, and sure enough, the system account has the administrator group in the token. Contrast that with, for example, the network service account. And again, we're going to time out waiting for the token to come up. Administrators won't be in the list. So that was done to reduce the possibility of damage. Services in network and local service that could get compromised, let's say due to a buffer overflow bug. Not that Microsoft has ever had such a thing, but in theory, let's say they had a security bug. Just in theory now. That service would be able to do less damage because it's not running with admin rights. So that's why there are more service hosts. And you also might be asking, so why are there more than one under the same account? By the way, here's network service. Notice users is in the list. Everyone is in the list, but no administrators. So it's a non-admin account. The reason that there are multiple service hosts is because some of the services that run under, for example, the system account, are not services that you would want living with this long list. I'll give you an example. The one below it, no, that's the spooler. There was another SVC host running under system. Where was it? SVC host. Oh, it was above. That's not a good example. Let's see. Well, I'll pick the network service one. The RPC service. The RPC service is a service that, in effect, invites strangers into his home that might be infected with some contagious virus. The RPC service may be configured to load third-party RPC, remote procedure call, server-side DLLs. You don't want third-party code in the same address space as your DNS client service. Now, this particular service host running under network service happens to only have one Microsoft service. But the RPC service is forced to live in his own address space because that service may drag in third-party code. And that third-party code could cause the process to crash. And the same is true for the other instances where you see more than one service host. It's because the services in that service host were forced to live by themselves because they may load third-party code. And that's why they're not allowed to live with their friends, their brothers and sisters. Okay, so that's a little bit looking at services inside a process. Now, frankly, if you look at most third-party services, let's take, for example, this is the virus scanner that I run. It's from, as you can see from the tooltip, Computer Associates. This is the virus scanner that Microsoft uses on their corporate LAN. So because my laptop is a member of their domain, I don't work for them, but I have access to their network. I'm forced to run their virus scanner. If we look, there are 3 service hosting processes implementing pieces of this virus scanner. But if we look at the list of services, this has 1 service, the next has 1 service, and the next has 1 service. And frankly, in my observation, most third parties don't take advantage of the fact that they could combine services into a single process. It's not a big deal, but it also seems to go against the objective of reducing the number of service processes. And by the way, that's something about the service host implementation. Service host is a Microsoft-only club. Third parties are not allowed to enter the home. So third parties are forced to create their own service processes.